Hey guys, welcome back to another Default Cube CG Matter tutorial, and I know it's been, again, a while since I made the last one, but please stop complaining because I'm back, and in this one we're going to be talking about the cross-hatching shader, which has a CG Matter video, but we're going to go into more depth in this, try to explain it better, and we're actually going to make a more advanced version that lets you animate the cross-hatching, which looks very realistic when you render it. I don't know what realistic means, but it looks better at 12 frames per second. And of course, here's like what one frame looks like with the freestyle and everything. So the goal of this tutorial is to kind of explain this network in a way that makes sense and to get results that look something like this. So the light changes how the cartoon shading looks. And before we start, just like the previous thing, all you need for this tutorial is a image that you can find on Google Images of a cross-hatching texture. You can just find this online. It's free. Google Images, or you can make this procedurally, but I would not recommend it. So once you have this image, I guess we are ready to get started. Okay, so this is what your Blender scene will look like. Actually, I'm going to make it full screen. This is what your Blender scene will look like, assuming that you haven't messed with your default scene. Has a cube, camera, light, you know this. So how do we make our cross-hatching shader? Well, before we do that, I like to pick an object that we can model or see how our material is progressing with. So I don't like a cube because the faces are very pointer. I don't know what that means. What I like to use is something like a sphere or a monkey, doesn't matter. So I'm going to use a sphere. You can hit Control 1, Control 2, Control 3 to subdivide by that level. So Control 2 is going to add 2 subdivisions and then shade smooth. So this is what we're going to be using as our reference, or I have no idea what the word I'm looking for is. Once you have picked your object, go to shading. And this is where the magic happens. We're going to create a new material that we can call X-hatch, that's short for cross hatching. That's what the X is. And yeah, now let's get into the hard stuff. Now, the way we're going to make this is exclusively a Eevee shader. It's not going to work with cycles. Oh well. So make sure that you're in rendered view so we can see everything Eevee has to offer. And then we're going to add a diffuse BSDF and plug that into the surface. So this is what it looks like currently, and it's of course reactive to the light because it's a BSDF. So now the question is, how do we take this light, the area that's white versus the area that's black, and convert that to where there is and isn't cross-hatching? Well, first of all, we're going to use a node called the shader to RGB node. So we have our diffuse BSDF being processed through a shader to RGB node, and you're going to notice that nothing really happens. And it in fact looks the same if we hide it effectively, if we actually let it go through that. For some reason, muting doesn't work with that node, but whatever. So it doesn't really do anything, but you're going to notice that it converts from this green socket to this yellow socket, which means we're not using BSDF information anymore. Now we just have kind of like a texture, if you want to think about it that way. It's just color information. So think about this as a simple conversion that only works with Eevee, because if we go to cycles, node doesn't work. So that's the limiting factor. This is going to let us use a color ramp node, which we could not have done before, but we're going to use this color ramp node to increase the contrast, make it more cartoony so the shadows are darker and the brighter spots are brighter. So we can just take our left handle, bring that up, and you can see already what that is doing. So we're just increasing the contrast. Again, if you plug this BSDF right into the color ramp, wouldn't work, which is why we're using this in-between step. Okay, so now we have very defined areas that again react to our lighting, and that also includes the radius of the light if we want to soften it, but we won't deal with that yet. And now what we want to do is incorporate our cross-hatching. So add in Shift-A an image. I don't know why I said Shift-A. I've already done it a bunch of times, but add in an image texture node, and we're going to load in, I guess it could be any texture, but since this is a cross-hatching tutorial, I guess we should use a cross-hatching image. And when we view this, you see it's wrapped on our sphere, and by default, since it's a image texture, it's going to be using UV mapping. You can see if we hit Control T. By the way, all the shortcuts, for the people who don't know, Edit Preferences, Add-ons, go to Node Wrangler, and enable Node Wrangler, which is going to let you use these shortcuts. So that was Control T. You can see it's using the UV mapping by default, but you can use any kind of mapping, just whatever you think would look good. So that's why I don't use these other ones. but in other cases, like the cube, it really wouldn't matter. Okay, so that is using UV coordinates. That's fine. And now we want to take this image and this color ramp and somehow incorporate them together. And the best way to do that is to mix them together. So either add a mix RGB or use some fancy shortcuts. And now these are mixed together with a mix RGB. So you can see one side gives us our color ramp only, other side gives us our cross hatching only. Instead, what we're going to do is we're going to set this to multiply. And then we are going to, let's say we increase the factor. You can see we kind of have what we want in that the cross hatching is there and it's reactive to the lighting, but we want our cross hatching in the opposite side, right? If this is like the moon, the dark side of the moon is where we want our cross hatching, unless you're going for an inverted effect. So, of course, the way we do that is we either invert the factor or we swap these sockets, which is what we're going to do. So swap the sockets, and now you see we're getting something that's a bit closer. And to make it a bit more obvious, we can play with the factor. Something like that. Not all the way to 1, but something pretty harsh like a 0.92. And you can see that we do have cross-hatching everywhere, but it is kind of incorporating that darkness, which makes it kind of look denser in some sense. So that's already pretty good. Okay, so we have this, we have our image, we mix them together. But now how do we get proper shading? Again, because notice that none of this is BSDF. I mean, I guess it's here in the beginning, but then we kind of lose that information. So not really a BSDF anymore. Plus, we want to get rid of the cross-hatching here. How do we do that? To do it, we're going to add a mix, not a mix RGB, but a mix shader, because we're going to be using BSDFs and stuff. Let's just plug that directly into the surface. So first of all, we're going to be using this kind of texture, just this color information. But then we're also going to be using this BSDF in the second socket. And then, of course, for our factor, where do we want there to be cross-hatching versus where do we not want there to be cross-hatching? Well, that is defined by our color ramp. Because again, you can see that kind of gives us this gradient. So we're going to use this as the factor. And you can see that kind of gives us what we want. It doesn't look good yet, but just the theory of it, the principles of it, they're there. So that's pretty cool. And then, of course, you could, there's a couple of things you could do on technicalities. Like, yeah, you could probably add in a BSDF here. Shouldn't mess anything up too bad. I guess it did, because if you think about it, this is more, technically accurate because this area isn't receiving any light because the light's over here, so it's going to be darker. But we're going for a stylized look, so let's get rid of that. So there we go. We have something that looks okay, at least in theory. So how do we make this look better? Well, first of all, the cross-hatching here, if we look at our camera view, this is huge. Like if you were to draw this, cross-hatching would be much denser. So we're going to add our texture coordinates back in, Control-T. And the nice thing about that shortcut is it doesn't just give us our UV coordinates, which we don't really care about. That's by default. It gives us this mapping node. That's what we care about because we can change the scale. And you can either change the scale uniformly by, dragging all three, or you can just, here's a trick, you could use a value. And even though this is a vector input, meaning it has three data inputs, we can use one input and it's going to copy to all three. So right now these are all 0.5, now they're all 1, now they're all 2, etc. So you can see this kind of controls our density. I think something like 3 or 4 is what I've been using. Don't want to make it too small, but you can already see that just that made it look a lot better. So again, before it was at 1, I believe, and now it's at 3 or 3.5, and it looks much better. I'll do 3.5. Okay, so that's the first thing that immediately makes it look better. The second thing is kind of unrelated to this whole network, and that is going to the render tab. Again, we're using Eevee and just enable Freestyle. That's just going to give us an outline. You see when we render, it gives us this nice outline. That's just a small thing you can add. And then also for the Freestyle, if you go to View Layer Properties, which is where our Freestyle settings are, we want to change the color, and this was their Discord recommendation, so thank you to whoever recommended that. We want to change the color, so Freestyle line style, and then color. Instead of a black outline, we want something that's a bit closer to gray, something like that. So now when we do it, hopefully you can tell this isn't black, but it's closer to gray. Looks much nicer. Okay, back to the material. Okay, so we have that, and remember, this is procedural in the sense that we can, I mean, I know we're using an image texture, but we can still control the fall off. So notice if we use our color ramp, we can control this fall off, how harsh we want it to be, also from the other side. So that's something you can play with. Kind of the harsher you make it, the more exaggerated cartoony it is. Or of course, you can use the more physical approach of using your light and just changing this radius, which you can see if we make it very big, now it's a very soft fall off. So maybe something like 0.3, 0.5, I don't know. And then also, because of the way we set this up, the intensity, the power also matters. So if we bring this down, notice that this area is completely white because that's where it's exposed to light. But if we bring it down, you're going to notice we're getting, soft cross-hatching over here. And then as it goes into shadow, it's much more intense. So that's a cool little feature. So let's see, that's looking pretty good. Then I would say the next thing we need to do, which I didn't explain in the CG Matter tutorial because I thought it was a bit much, is we want to be able to animate this cross-hatching. And there are a couple ways to do this. You can either have one cross-hatching here, duplicate this, and change the texture coordinates, and then swap between these back and forth as if you drew one frame, then drew another, and it would oscillate. But there's an easier way. And that easier way is we're just going to use rotation. So notice that here's what the cross-hatching looks like, but if we increase the Z value, it effectively gives us a new seed. Or we could change like X and Y, or Z and Y, or whatever you want. Meaning that we can use a combine. This time I'm using a combine XYZ instead of just plugging the value directly in because I don't want all three inputs to have the same value. I want only one of them to be affected. So that's combine XYZ, and then we're just going to add a value to Z. But it could be X or Y, it doesn't matter. Meaning that now this controls kind of like the seed. I mean, right now it just looks like it's very nicely rotating, but that's because we can see the, in between points. But if it just goes from like 0 to 5, it just looks like a random seed, So what we need to do is have this change every frame, meaning we probably want to use drivers. So we're going to use we're going to open up the timeline. So open up a new window, change it to timeline, and then we want our current frame number, which, determines the frames, what frame we're on. We're going to right click, copy as new driver, and then paste driver, meaning that this information is being sent into here via driver. So now if we go to frame 2, you can see this is 2, then 3, then 4, then 5. And then the reason this is switching so quickly, you're thinking, oh, we're changing by 6 degrees, then 7, then 8, it should be smoother than this. I think it's because it's by default it's using radians, so each time we do this, it's like 56 degrees changing each frame. So now if we look at this, it's kind of like crazy, which is, it's close to what we want, but it won't really look like the animated look when we render it. So again, this is another Discord recommendation. In the output tab, we don't want to play this at 24 frames per second. When you animate things, something that you draw and you do this cross-hatching, it's probably less frames per second because it would take a lot more work to do a higher FPS. And the standard ones are 12 and 8, I believe, which aren't options here. So just go to custom, type in the number. I'm probably going to use 12. So now it's a bit more contained. Of course, it's going to look a bit weird in the viewport, but it's looking okay. You can also experiment with 8 or even something lower. I would say that 8 is kind of a very, very stylized hand-drawn look, whereas 12 is kind of like more traditional animation. But I haven't done 8 before, so we're going to try it. Okay, so now let's kind of set up our scene. I'm just going to make this a bit bigger, move our camera up a little, and then we also need to adjust our light, because that is, again, what is driving this shading. By the way, this works since it's BSDF driven. We can have multiple lights so that it works with any kind of setup, right? It doesn't have to be one light. Okay, so I just want to set up this light so it's a bit closer. Just trying to copy that render I did before. We're going to keyframe. That's I, location. Again, we're going 8 frames per second, so if we want a 4-second animation, that is 32 frames. So let's go to the last frame, frame 32, and just move it over here, keyframe. Let's see it. So now you see we have this very nice animated look, and don't forget, if we go to render, we're going to have that nice border, which you can stylize even a bit more if you go, again, to Freestyle, and then we go to our Freestyle line style. There's a couple things you can do, like you can make the lines thicker, you can make them dash, so you can enable dash, make this like 2, 2, and 2. Not going to explain what those do. It's basically the spacing and the length of the dash lines. So here you can see now we have like dots instead of a solid line. And this is just really your preference. I would say I kind of like the solid line, maybe, although dash looks pretty good. You can change the thickness, which I think I'm going to do, make it a bit thicker, so something like 6. This is all just your preference. Okay, that's a bit much. let's do 4.5. Okay, there we go. And then let's just do a quick preview just to see what this looks like rendered. And the nice thing is, even though we're forced to use Eevee, in this case, it's a good thing because it's going to render very quick. So I'm doing all this to render out a video. FFmpeg, MP4, high quality, doesn't matter. And then just save it to the desktop. I'm going to call this tutorial render boy. And let's render. Should be pretty fast. Now you're going to notice that it takes a bit longer than you might, be used to for Eevee. And that's because of this freestyle pass it has to do. And we're going to do this, and then I'm going to show you one more thing to really elevate this above and beyond. But already it's looking very hand-drawn, very good. We only need to make it to frame 32. By the way, if you're wondering about the glasses, I don't know. Stylized tutorial. Okay, let's see. So this is what our render looks like. Again, it's going to be a low frame per second. That's intentional. So that's what it looks like. I might prefer 12 frames per second, but this is looking interesting for sure. So one thing that's going to make this kind of go better, it's going to make it better, is you see that we're basically blending between a BSDF and an image, but there is texture, but there's no texture to it, if you understand what I'm saying, meaning that we don't have any normal mapping. So to fix this, what we need to do is this BSDF that we're using both to process and to go into our mix shader, we need to separate these tasks. So I'm going to duplicate it, and I'm going to use this for the mix. So basically, we now have two separate BSDFs, one doing this whole shader to RGB conversion, one handling this. So what I want to do with this is, effectively, we haven't changed anything. There shouldn't be any difference between using this versus this. Shouldn't matter. But what we want to do is include our normal mapping. So we're going to use this, which contains our cross-hatching and a couple other things to drive the normals, which is going to look funky. Or at least, I don't know, it's going to look like nothing at all. What we need to do is this in-between step, it needs to have a bump. So we need to change this color information into normal information. So bump going into height. And now you see we're getting something that kind of feels like it has depth to it. But of course, that is too intense. 0 has 0 intensity, so you pick something like 0.2, 0.3, 0.3, let's say. And you can see that we still get a bit of normal mapping, even where the area is all white, but it should be more subtle than in this area. And then, of course, you can also invert it to whichever one you feel like makes more sense. If you want the lines coming in or out, doesn't really matter. Like if you want where there's pencil marks to be slightly raised because there's ink, that's fine. Doesn't really matter. I'm just going to keep it as usual. And if we do a render of, let's say, this frame, you might not notice it, but it gives it much more texture and depth because all this normal mapping is going to react to the lighting, which is pretty cool. Okay, so now we have normal mapping, and I guess I should also mention, okay, why didn't you do all this, but just use the original BSDF? And let me tell you. So let's say we had the original BSDF, and then we send this converted normal into here. You're going to see that this has an issue because it's using circular logic, right? It's first supposed to calculate this BSDF, which is going to give us this color ramp, right? And then we go through all this, but then you can't go backwards and have it then reference that. It doesn't make any sense, which is why we have this red connection. It means it doesn't make sense anymore. So you don't want to use circular logic. Shader to RGB is one of the few cases where you run into that problem, so try to avoid it. Okay, so now we have this look, and I guess The only thing I want to change is, first of all, 12 FPS, although 8 does look cool. So now it's going to be a bit smoother, but it shouldn't like flicker too much. And then I'm just going to save it because apparently I didn't. And then the last thing I want to do is make our scene a bit more interesting. We can add a plane and we can apply the same material. Again, anything that has UV mapping is going to work. Now you're going to notice that in this case, we might want to create a instance of our material. So this is xhatch001 and our sphere has xhatch. And the reason for that is I want to make this cross-hatching have a different density. So we need to make it separate to control it. So you can make this one like denser like that if you want. And you're going to see that all the principles kind of apply to whatever object we're looking at. Meaning if we make our light much brighter, let's say 2000, you can see that even on this plane, there's only cross-hatching where there is shadow. So where it's close to this light, there isn't much. There's a bit of this normal mapping. But yeah. And we can apply this to any object. So monkey, Control-2 to subdivide, shade smooth. Apply our xhatch1. And again, you can play around with the scale depending on the object, or you can even use different coordinates, so maybe generated coordinates. Although I haven't found a case where it looks good. But yeah, you can see what it's doing. And yeah, I mean, I don't know if I should like render it because really I've set up the project that I've shown here. The only difference between this and what we've set up is after I rendered it, I took the contrast and bumped it up a little, which is something that you can actually do in Blender. So let me just quickly do that. Shade smooth, scale up a little, xhatch. Okay, so this is what our normal frame looks like. And then to bump up the contrast, I think we can just go to the render tab, and then under color management, we can change the color management. So we can, in look, we can do very high contrast, which is going to give us a very stylized look, or we could do something else. But you can see that this kind of intensity looks much better. And you know what? I'm gonna do a render while I promote my Patreon. So thank you everybody for watching this tutorial. I hope it made things a lot clearer and you learned a bit more about this whole process. Of course, there's a pole up here, but that's just because it's a sphere. That's how the UV mapping works. But anyways, if you enjoyed this tutorial and you want to help this channel continue making tutorials, because this is my job, the best way to ensure that is to donate over to my Patreon. I say donate because it's kind of an act of generosity, even though you do get perks like Discord access, early access, and some tutorial files occasionally. For this one, I actually sent the tutorial file. So anybody who wants to become a patron, thank you. It's greatly appreciated. But I hope you enjoyed this free tutorial. And let's actually see the render now that it's done. It should be here updated. So now it's 12 frames per second. You can see that's looking very stylized, and that's how you make it. But again, Patreon for anybody who's interested. And yeah, thank you for watching this tutorial. I hope it was a good one.